Hello, geometry students. Welcome to lesson 10.2, areas of trapezoids, rhombuses, and kites. All right, one thing that I want to talk about first is the height of a trapezoid. Now, keep in mind that this figure here is a trapezoid. A trapezoid has two parallel bases, or I guess a set of parallel bases. It only has one set of parallel sides, so you'll notice that these two are not parallel to each other. So the height of a trapezoid is, and we're going to just start right here, it is the perpendicular distance, often referred to as h, between the bases. I just want to remind you that the bases are the two sides that are parallel to each other. So now that we know what the height is, then we can talk about, let's see. Well, actually, we'll get into the area here, but up here, the bases are the parallel sides, and the legs are the non-parallel sides. And the height is the distance between the two parallel sides. So now we're going to go to the area of a trapezoid. The area of the trapezoid is 1/2 the height times base 1, or base sub 1 and base sub 2. Okay, it does not matter which one you count as the first or second base here, because again, addition is commutative and you're doing that before you do any multiplication. Okay, so here we have an example. It says approximate the area of Arkansas by finding the area of the trapezoid. So you'll notice that the trapezoid is here to here, here, and here. Okay, so we have area is equal to 1/2 the height, which looks like 242 miles, 242, times base and base. So 190 plus 250. Okay, if we add those together, we get 440. Also, I can take half of 242, that gives me 121. So I have 121 times 440. Multiply that together on the calculator, you get 53,240 miles squared. Again, miles and area is always square units. Okay, so now it says properties of special right triangles can help you find the area of a trapezoid. What is the area of trapezoid PQRS? Well, right now we do not have a height, so we need to first find the height. The height, remember, is perpendicular to the base, okay? I do notice that this is now a 30, 60, 90 triangle. So I'm going to draw that off to the side here. Okay, so here's my 30, 60, 90. I know this angle here is 60, but otherwise I'm looking for the height. So what is this little piece here? Well, this little piece would be 7 minus 5. So this little piece is worth 2. So now if you think back to your special rules of 30, 60, 90, the long leg was always square root of 3 times the short leg. So now that we have the height, now we can calculate the area. So area is equal to 1/2 the height, which is 2 square root of 3, times base 1 and base 2 added together. So base 1 and base 2 added together is 12. And then half of 2 is 1. So this here becomes 1 times the square root of 3, which is just the square root of 3. And then when we multiply them together, we usually put this number in front. So we have 12 square root of 3, and that is meters squared. So again, we had to use our 30, 60, 90 triangle rules to get the height, and then we use the height into the area formula. All right, let's take a look at the next side. So now we're on to part 2, finding the area of rhombuses and kites. Rhombuses and kites have perpendicular diagonals. That means that their diagonals meet at 90-degree angles. So perpendicular. So that means that their diagonals meet at 90-degree angles. Diagonals meet at 90-degree angles or right angles. Okay, the area of a rhombus or a kite is half the product, meaning that we're multiplying the product of the lengths of its diagonals. So we can write that like so. Area equals 1/2 of diagonal 1 times diagonal 2. You can also see that read d sub 1 times d sub 2. Okay, so here let's find the area of this kite. Okay, so area of kite is equal to 1/2. Now we need this whole distance, okay? It's 5 plus 2, so that is 7. And then we also have this entire distance, which is 6. Okay, so 7 times 6 is 42. Half of 42 is 21. If I look back at my units, it is meters, so meters squared. Scrolling up just a bit, the fact that the diagonals of a rhombus bisect each other can help us find the area of a rhombus. So that wasn't necessarily the case in the kite. Obviously, these diagonals did not bisect each other if this part was 5 and this part was 2. But in a rhombus, the diagonals bisect each other. So now we're going to use that information to find the area of the rhombus. Area is 1/2 of diagonal 1 times diagonal 2. Well, if this part is 20, the other half is also 20. That means the whole diagonal is 40. And then if this one's 30, that piece is 30. So 30 and 30 is 60. All right, so now I know that half of 40 is 20. 20 times 60 is 1200. Looks like I'm dealing with feet, and that would be squared. Okay, now looking at this example, it says find the area of rhombus ABCD. Well, here, do not get tricked. They gave us the, if we broke this into triangles, they gave us the hypotenuse, but we need to find the leg so that we can figure out the diagonals. Let's see, if I divide this by 3, I can get to 5. If I divide this by 3, I can get to 4. This must be a 3, 4, 5 triangle. So because it's a 3, 4, 5 triangle, I can simply do 3 times 3. This side must be 9. Because it's not exactly 3, 4, 5, it's multiples of 3, 4, 5. So 9, 12, and 15 simplify down to 3, 4, and 5. Okay, but we can check our work using the Pythagorean theorem because you're not always going to be presented with Pythagorean triples. So 15, we can plug it into a squared plus b squared equals c squared. A and b are interchangeable, of course, but I'm filling in the Pythagorean theorem here. Okay, b squared would equal 81, b equals 9. So that was accurate. And so now area is equal to 1/2 diagonal 1 times diagonal 2. So I have 9 here and 9 here, so that's 18 for one diagonal, and I have 12 and 12, so that's 24 for the other diagonal. Half of 18 is 9, so I have 9 times 24. 9 times 24, let me zoom up here, is 216, and we are dealing with meters. So the area of that rhombus is 216 meters squared. So notice how you're still going to have to use Pythagorean theorem or your rules of 45, 45, 90 and 30, 60, 90 triangles in order to help you find a piece to plug into the area formulas. And that's it for lesson 10.2.